anything whatsoever, by all means, put those questions into the Q&A dialog box, and we'll at least offer you an opinion, if nothing else. So with that, I'll introduce Nate Collette.
Hey guys, Nate Collette here. I've been an application engineer at Altium for about 2 years now. I started out with Altium Designer, and then I had this great chance to come work over with PCB Works.
So with that, Sanu, do you have a little bit you want to
Thanks, Lawrence.
Yeah.
Thanks, Nate. So the agenda for today, guys, we'll quickly go over it. We'll do an update for Javelin, just what we can do, what we can provide, and where we're at right now. A quick look at the product life cycle solutions that we have, and then we'll get right into electrical solutions, and then we can discuss some next steps that you would want to take, and open it up for any questions that you can still type during the whole webinar. But in the end, if you want to, we can answer them, and we can even answer them offline if they're getting if you're going over time here. So Javelin Technologies, of course, you all know us already, in business since 1997, more than 80 people. We've been growing like crazy, and we are, have offices across Canada. What does that mean for you? It means for you that we are there to support you from, morning in, our East Coast till evening in the West Coast. So it is, it's great for support and services. What we've been working with customers here is that we understand that it is not just about throwing a box at you with a solution. Solutions for every stage is what our customers are asking for, and that's what we're bringing to the table. We understand that people are important, and that's the brains behind the operation, right? And we want to help you guys, retain that, onboard that, train that, and help them develop ideas and concepts as well. So we want to work with you and your people. Technology, of course, we bring to the table from SolidWorks, from our other partners. Whatever we feel is what the customers are asking for, we want to work with you guys and work with our partners to bring that in, as you're working with Altium and PCB Works today. And we want to take all that and, of course, help you manage, collaborate, and help have the process handy so that you can take that into manufacturing, where that's the key place where you make the money. And we want to make sure that we can help you with the process and manufacturing end of it, with either 3D printing or just having documentation right to make sure that you have a great production cycle without making any mistakes, which you can catch on the design side of it. We can discuss that in more detail, any areas that you want, but for today, of course, we'll jump right into our electrical solutions. You've already seen one of our electrical solutions. We've been working with it for a while. That's a SolidWorks electrical solution. I'm introducing that here because we'll be talking about that in a couple of days as well. And there are some parallels to draw here when you look at PCB Works today. SolidWorks Electrical is for your electrical schematics, your high power, low power control schematics for inter-system design and cabinets, and you can add motor controls, and you can do some PNID and hydraulics as well if you so inclined. And the whole system is based on a single source where you're collaborating with SolidWorks for your 3D cabinet layout and your harness design, cable design, wire design, and all that. So one solution for collaborating between 2D, which always used to be different than 3D, bringing that together. And if you want to know more, learn more, we have how we can help you reduce manufacturing cost demonstration coming on Thursday, November 12th between 2 to 2:30. Let us know and we can provide you with a link. But what does that electrical have to do with PCB Works? PCB Works, and we'll explain, Lawrence and Nate will go on and explain that, is PCB Works lets you do similar things about collaborating on the electronic side of it, or the PCB board design side of it. So essentially, our electrical solutions, we want to make sure that you are working together between your electrical, electronics, and your mechanical department, so you can produce a more streamlined product. Having said that, I think I'll let Lawrence and Nate show you more information. But before we do that, let me launch a quick poll question just to understand what you guys are using today to do your PCB designs. And with that, I'll start transferring the control over to Lawrence there. So that's a question, and it'd be great if you can answer it. So lots of responses coming in. Quite a few guys are using Altium Designer. Some are using, Eagle. There's some good old drafting paper as well. That must be fun. But we can help, of course. I know we understand that there are requirements for simpler design, and then there are requirements for getting this design up to the level of the PCB board design that we're talking about today. With that, let me close the poll, and I will pass that on to Lawrence. Lawrence, you can take it away.
Great, thank you, Sanu. So yeah, interesting on the poll. Couple things I would point out right up front. So first of all, when we talk about those using Altium Designer, please keep in mind that all of this capability that you're going to see today, specifically the real-time interaction with SolidWorks, we also make available to our Altium Designer users via what we call the MCAD Code Designer solution, and that can also be facilitated via Javelin. So for those that are using Altium Designer, you can access this exact same capability, and we'd be happy to discuss with you about how you can go about evaluating that, purchasing it, etc. Secondarily, what I would say is with Eagle users, in Europe specifically, Eagle represents about 60%, believe it or not, of our business in Europe. Keep in mind, Altium has grown quite aggressively over the past 5 years, doubled in revenue over the past 5 years, and typically now growing about 15 to 20% a quarter. In Europe, that growth is really coming from a significant amount of Eagle users. Now, I think PCB Works makes tremendous sense when we talk about the transition from Eagle to an Altium product, because the PCB Works user interface is quite a bit simpler than what we have in Altium Designer, and it's a nice sort of in-between from a capability, PCB design capability, and price when we talk about moving from the sort of Eagle ranks into the world of real sort of commercially professional PCB design. So I think those are two good candidates of people that should potentially take a look. So with that, Sanu, can you guys see my screen now, the PCB Works screen?
I don't think so.
Let me make sure. I see the problem.
Yeah, now we can see your screen.
All right, let me just make this presentation mode. How about now? Can you see the presentation screen, or do you see the...
See the other screen, not the presentation screen.
All right, how about now?
Now we see both.
You see both? All right, 3, 2. All right, how about now?
Perfect.
Okay, very good. Sorry about that. All right, so I'll just kind of run you through the paradigm that we're looking to address here with PCB Works. Shouldn't take but about 10 minutes, and then we'll turn it over to Nate to walk through the product. And then at any point, as I mentioned before, go ahead and fire your questions into that Q&A dialog box, and one of us at any point in time will get to it. Please do try to use the questions dialog versus the chat. That allows us to get to them in a nice linear fashion, and as well as go back if there's something we can't answer. It allows us to go back and answer your questions after the event. So just quickly here, show you the paradigm here. So obviously what we're talking about here is SolidWorks, because this product is specifically developed in conjunction with the Dassault guy, SolidWorks, to work with SolidWorks. So really what we're talking about here is now product development. So if you look at SolidWorks and you look at Altium, historically, a big part of our success individually is that we've, in each of our domains in the mechanical world, SolidWorks did a real phenomenal job back in 1995 of really offering a cost-effective solution for mechanical design that ran on a personal computer. But more importantly, what it really did was unify that process. It really brought together, and Sanu touched on this when he mentioned electrical, really brought together a bunch of individual disciplines in the world of mechanical design underneath the hood of one product, in that case SolidWorks. Now, that's really what's powered Altium's success over the past really 30 years in business, has really been that singular, or what we call unified design capability. So we've unified the process of really designing electronics, and specifically printed circuit boards. And that's really what people come to and they know and love about Altium. Now what we're talking about doing is, with this paradigm, PCB Works and SolidWorks, is now really allowing you to look at product development now in the same way that your end users, your end customers view the products. In other words, they're really looking for a singular overall product experience versus really evaluating your products based upon the look, feel, and taste of your product. In other words, the mechanical or industrial design. Likewise, they're not just looking for the bells and whistles that would be contained, or the intelligence contained with the electronics. It's really the combination of the two. Now, unfortunately, there is a divide between these two worlds, and it's a divide that quite literally penalizes you for making iterations to your product to find that optimum balance. And traditionally, that process looks like this. What we find more often than not always, but in most cases, it starts on the mechanical side. So you'll start with a block, and you'll begin really sort of chiseling that block, or coming up with some sort of a form factor that you want to use. In this case, we're going to use this remote control car as an example. And then ultimately what you're going to get out of this thing is some sort of board outline. Okay, and this can be facilitated or handed off to the other group in a number of different ways, but ultimately you're going to do some sort of rudimentary dimensioning. Maybe you're going to put some holes into this board, some mounting holes for standoffs, that sort of thing. Maybe you'll put some high-profile components on this thing, and then ultimately get it to a point where you're ready to package that up as a black box and stick that. Typically, we see this being done in an email. Can be done using network folders, can be used or done using products like SolidWorks from Dassault, from SolidWorks, or maybe it's a combination of different things. Maybe it's DXF combined with a step file, so on and so forth. But the point is, it's a static representation of that design when you got to some sort of milestone in the process. And then you'll send that over to your counterpart on the electronic side, or maybe it's you, and they'll unpack that thing, pull out that black box, and then they'll begin the process of printed circuit board design. So they'll put on, in this case, some LEDs, some semiconductors, so on and so forth. And then what they'll find is, well, actually, we need to make some concessions for component placement. Maybe the board shape isn't quite going to accommodate our electronics. There's some sort of problem here with the mechanical outline. And then what will they do? Well, they'll do the opposite. So they'll package that up, put it in some sort of black box format, send it over to the other side, and then you'll do this over and over again. And what you'll end up with over time are sort of 1, 2, maybe 3, maybe 4, or maybe a desktop full of these black boxes. And then ultimately what happens is we find people labeling these black boxes with some sort of version control system. Typically it's the product name _ V.1, V.1.1, V.1.2, and then ultimately what happens is, obviously the mechanical people and the electrical people come out of sync. And this is also a very serial process. So ultimately at the end, nobody knows which version is the correct version, and it actually does penalize you. Now, the research that we have found in the industry says that, at least in electronics, each of these design changes, each of these black boxes during the design phase can cost an organization a little more than $1,800 per, and that's obviously in time, man hours, etc. So $1,800 per each black box or engineering change order. Now, obviously this becomes very expensive, and what companies then end up doing is this. So let's say, okay, in order to prevent this versioning issue, what we're going to have is one person or one party working on the product at each time. So in this example here, we have the mechanical designer working, making design changes, massaging the design, perfecting the design, while the electronics design folks are not doing anything at all. And then likewise, we'll flip that around. And on, or maybe they're both not working because of some data integrity issues that you have to deal with. And ultimately where this gets to is if you spin a prototype, each of those prototypes, at least in the PCB world, of a moderately complex nature, typically costs an organization about $8,900 and some change. Now this same research from the Aberdeen Group in February of 2010 also stated that the average company would spend, again, moderately complex, an average of 14.1 prototypes per design cycle. I felt that was a bit much, but just used a simple example of, let's just say, instead of 14, that was 4. Well, that's a grand total of $35,000 and a little bit more and a little bit better, in conjunction with the cost associated with early stage design changes. Now, in addition to these costs, if you release a design and there's a design change that doesn't need to be caught, or should say hasn't been caught until it's released for manufacture, those design changes actually cost your organization almost $10,000. So this is what I'm saying, is that the traditional parallel design process, when we talk about mechanical, or excuse me, product development, actually penalizes you guys for doing what's best for the design and ultimately best for the end product. And that's exactly what it is we're addressing with PCB Works. And this is all built on Altium's 30 years of PCB history. We've been in the PCB business since about 1984, 1985, one of the original companies in this space. And all of the things that have put us on the map, and we're easily one of the dominant 2 in this space nowadays, are all built into PCB Works. So all of the sort of Altium DNA that's really made us successful has been built into PCB Works. And really the byproduct in another area where we've been put on the map is this ability to really manage design data. What I say, and have for years, is that more than anything else, what Altium allows you to do are these 3 things. Make, propagate, and most importantly, document design changes, and do that as effectively and efficiently as possible so that you end up at the end of the day with the most effective design for your end customers. And then of course you throw on top of this now this seamless collaboration that we've developed in conjunction with SolidWorks. This product has some real potential, and early indications are that it's going to be very, very successful. So with that, obviously any questions, go ahead and stick them in there, but I'll go ahead and turn it over to Nate. You want to give Nate the controls there, Sidnu?
Absolutely. Thanks, Lawrence, for the information. Nate, I'll give you that control. And while I'm doing that, why don't I have another poll go on for you guys so that you can let us know, what would, hearing from that, what would you like to change? What is that you want to see getting better in your organization and your design tools today? It seems like everything is getting sort of an exact response, and which is great. All of it is more than 50% have selected all of it, which is great. Accurate BOM and integration with SolidWorks, of course, being there. We have a couple of holdouts here. I would encourage them to start setting that up, and guess I'll close the poll. We have 2 or 3 people who haven't responded, but I think more than 70–80% have. So we have. Let's close that, and Nate, take it away.
All right, thanks, Sidnu. We'll take a quick look at PCB Works here, just focusing on what really makes it unique. As Lawrence was saying, PCB Works is a new product, but Altium isn't a new company. And Altium's really taken their 30 years of design experience and applied it directly right here to PCB Works. and that's apparent in the unified design interface. So it's really everything that you need in one tool to create a professional quality PCB. You're going to have your full-fledged schematic editor.
Hey, Nate?
Yeah.
We don't have the screen.
Oh, it's not showing the screen? Here, let me see if you guys can see it now.
Yes, we can. Maybe
Okay, thank you. I apologize for that.
Start back up again.
Yep. So I was just explaining a little bit about this unified design interface. And traditionally, ECAD packages, they've been a compilation of multiple different programs where you would import and export out from the different tools. Maybe you'd create your schematic and then export out to a PCB editor and then export out again when you're ready to do your fabrication. And this unified design interface, it really has everything right here in one tool. So this is the schematic editor, the PCB layout, of course, as well as library management so that you can create schematic symbols and PCB footprints, as well as everything else that you might need like version control and simulation capabilities. PCB Works has gone with this nice ribbon interface here that you'll see at the top. This is really popular in the industry. It'll be familiar from programs like SolidWorks and even Microsoft Office. You'll notice as I flip through these different editors, all of the commands in the ribbon will change based on which editor I'm currently in. And I can pretty much work through a design from left to right on this ribbon, working through my home menu with all my common placement commands, some more advanced features here in the tools menu, and then finally the outputs when I'm ready to generate Gerbers and fabrication. One really great feature that you get with your subscription to PCB Works is access to the Altium Content Vault. And right now in here we have over 400,000 components, and we're always adding more. We have a dedicated team that's always keeping these components up to date and adding new ones here. I'll show you a couple things that you get with every single component here in the vault. So I've just selected Texas Instruments here. I'm just the first current shunt monitor here on the list. And you see that you get your symbol, of course, as well as your PCB footprint, and then even a 3D model there. And then, of course, you'll get all of your different parameters and links to supplier data sheets. But the really valuable thing in here is this live link to supplier data that we have. This is great so that you can pick the right component the first time, something that's in stock and available. We actually have visibility into a ton of different distributors' websites so that we can get the real-time pricing information from them. And you can even take this information and add it to your own components that you create yourself or even import from another program. And you can do that just by right-clicking any component and adding a supplier link right to it. The Content Vault is really nice because there's so many components in there, but maybe there's not a component that's exactly what you're looking for. You can actually take any component out of the vault, the symbol and the footprint, and then modify them to suit your needs. But we won't spend too much time on that. I know everybody's really interested in the collaboration, so we'll take a look into that. I have SolidWorks 2014 on here, and I've just been creating a basic PCB board shape. This is for a stepper motor driver. And then here's the stepper motor. I've kind of just taken the bottom of this body and then extruded it out to the board outline. And I want to take this board outline and send it over to PCB Works so I can start doing my layout on it. And before I do that, I should really explain that there's three parts to PCB Works. There's the application that we were just looking at here. That's PCB Works itself. And then within SolidWorks, I have the SolidWorks Collaboration add-in, which you can see right here on the right side of the screen. And sitting in between these two programs is the collaboration server, or the vault. And that's where all the synchronization and the differencing will happen. That's where you'll be pushing your designs to and pulling them from. And I can do that right here from my SolidWorks Collaboration panel. You'll notice in here I have a nice history of comments. So anytime anybody's ever made a change, they can put exactly what they've changed, and it'll show that the date and the time that that change has happened. And it'll even show their username here. I'm just using a default ECAD and MCAD user, but of course you can create as many users accounts as you wish. Let me go ahead and push this board over and enter in a comment. So I'll just hit the push button, and then just enter in a quick comment and hit the post button. And this is going to upload the design over to my collaboration server where I can pull it in on the PCB Works side. I've just opened up a blank document here. You'll see it's just the default board shape, just a basic square there. But I can open up my SolidWorks collaboration panel here, and it looks exactly like it does on the SolidWorks side. You will notice, though, I have a notification here. Anytime that a change has been pushed and my design is not synchronized with it, I'll be notified right away so that I can go ahead and view those changes and see exactly what the difference is. And I can click through this list of changes and I'll see a great animation of the proposed change, so I'll know exactly what to expect. There's not going to be any surprises or anything like that. And I can just hit the accept button and then go ahead and accept that change. Now my board matches exactly what I've created in SolidWorks. There won't be any confusion why it doesn't fit the enclosure later. I know a couple times I've held a board in one hand and an enclosure in the other hand, and for some reason they just didn't line up. And it's always a tough conversation why and what needs to be reworked. And now that I have my PCB board shape that matches exactly what I've created in SolidWorks to fit the enclosure, I can go ahead and bring over my components and start routing it. I've already done the schematic layout here, and I've wired it all up, so I'll push these components over to my PCB using our powerful engineering change order. I'll just go into my project menu and do an import changes. And here's the engineering change order. You'll notice it's going to be adding all of these components here. It's going to also be adding all of those associated nets that I've already wired up. And it's even going to create some classes here to make my design rules a lot easier. And of course I can choose which ones I want to accept or not accept, and even create a report for my records to save. I'll go ahead and just execute these changes. All right, looks good. And now I have all of my components nicely laid out to the right side of my board here. I can start placing them around the board. I won't spend too much time on this. I'll just kind of drag these around and then push them over so you can see that bidirectional collaboration to SolidWorks. And just like I did in SolidWorks, I can hit the push button here in the collaboration panel and then enter in the comments. And on this board, I've chosen just to attach step models to my footprints. So this is actually going to upload all of those step models to my collaboration server, where I can download them on the SolidWorks side and convert them into solid parts. A nice feature about PCB Works is you can actually attach those native solid parts and parasolids right onto your footprints now. So I do have the option to attach solid parts directly in PCB Works, and then I can push those back and forth to SolidWorks. So here I am back in SolidWorks, and you'll notice I have a notification here, exactly what I entered on the PCB Works side. I'll go ahead and view that. And just like I did in PCB Works, I can look at all of these proposed changes and actually click through them so that I can see a great little animation of exactly what to expect. Again, no surprises here. And I'll go ahead and just check all of those and then go ahead and accept them. And you'll see in the features tree, it start to fill up with all of my different solid parts there. All right, great, looks good. Looks like exactly what I've created on the PCB Works side. And then of course I could attach this right onto my enclosure so that I could do some clearance checking, make sure everything fits correctly. Maybe there's some critical component placement that has to happen, like these headers would have to fit a hole in the enclosure or something like that. I could very easily take care of that here on the SolidWorks side just by dragging those into the position that I need. And then I can push those changes right back to PCB Works. And then I'll go ahead and open up PCB Works here, and you'll notice I have another notification. I'll go ahead and view those changes. And I can check out those animations again. I think they look really cool in the 3D mode here. I'll go ahead and just accept all of those. And the real-time clearance detection works great in the 3D mode too, based on the design rules that you set up. All right, so now it matches exactly the movements that I've made on the SolidWorks side. Let me go ahead and just route this board very quickly so I can show you the export options that we have that include copper. Let's see, I won't spend time manually routing this. We have some really great differential pair routing and multi-routing, interactive routing, complete with conflict resolution modes, such as hug and push and all of the popular ones if you're familiar with Altium Designer. But I'll go ahead and just rotate some of these around to make the routing a little bit easier for the auto router. It doesn't look too bad. I'll go ahead and just invoke that command from the Tools menu and then the auto router. And I'm just going to use a default 2-layer board strategy here, which will automatically place any vias that it needs and do routing on the bottom layer as well. All right, looks good. Now I'm going to go ahead and export this board out into the ParaSolid format to show you that great copper information. And I can do that right here from my Outputs menu. And I think I'll just put it on the desktop. And here's those copper export options. I can choose not to export my copper. I can choose selected copper only, certain layers, or I can export everything, including the pads and the vias associated with components, which I'll go ahead and do now. And that message is just saying I haven't placed an origin, but it will do that automatically for me. And I've tried to do this with step models before, and it's just created these huge files that have taken forever to load and eventually crashed SolidWorks most of the times for me. But with ParaSolid, it's a real nice small file. Let's check out the size here. So only about 8.5 megabytes or so. And they load up relatively quickly for all of the data that's inside them, which is really nice. And these are perfect if you want to do any kind of thermal analysis or simulation, or even export out from SolidWorks into another simulation program. And when this comes in, you'll notice in my features tree on the left, it's going to have all of my different nets there, and within all of the nets will be all of the associated primitives, such as tracks, pads, and vias. Let me go ahead and make this transparent so we can see that great copper information. All right, looks like it came through very nicely. And that's just a quick demonstration of some of the capabilities of PCB Works. I do encourage you to enter any questions you have in the questions panel, and we'll go ahead and address those right away.
Thanks, Nate. That was great. And thank you everybody for joining us. This has been great. I wanted to ask you, how did you find this information? What did you like about the webinar? Should you have more questions? Of course, as Nate already asked, if you can ask us questions, that would be great. And we've gone over a little bit here by 5 minutes, and I apologize for that. But it was such great information that I couldn't. I'm sure everyone enjoyed it. So, and that's what the polls are saying. It was most people found it to be useful. Some need more information, and we can get in touch with you. If you have any questions, again, feel free to email me or put it in this, and based on the response, we'll get in touch with you so that we can help you and get more information about it. Having said that, again, wow, this was the question that was most answered in the entire presentation, so that is great. And it's a steady mix of, it was great, had good content. I see a few folks which were expecting more information, and we will do a much more informative webinar or informative one-on-one session with you if you need more information. And again, thanks Lawrence, thanks Nate, it was great. Let's do this again sometime.
Thank you, Sanu. Appreciate everybody. And then, you know, if you want to take a deeper look, absolutely 100%. Love to get you access to an evaluation, get you more information, etc. Just reach out to your folks there at Javelin, and we'll take it from there. Thanks, Sanu. Thanks, Nate.
Thanks. I'll set off to finish it off by just saying that the next steps, as we discussed here, the next step essentially is, if you have any technical questions, you can always ask that, and I can get Nate involved. I can answer a few for you, and of course Lawrence can as well. As Lawrence already mentioned, we can get you a trial if you want to get your hands dirty with it. It's a great trial. I've done it myself, and I think it works out so much easier. And we can have the ROI discussion and any other discussion that you'd like to see how we can help you get this in your environment and help your team get better at it. Thanks everybody again, and I'll see you next time. I'm recording this, so if anyone wants a recording, you can let me know. I'll be sending it out anyways. Thanks again. Have a great day.
Thank you, sir.